Hey guys, so now we're looking at law of sines and law of cosines. So if you remember from our last session, our introduction to trigonometry, I showed you the acronym SOHCAHTOA, which was the sine of an angle, let's say theta, is equal to the opposite over the hypotenuse. Then we had cosine of an angle, theta, is equal to the adjacent over the hypotenuse. And lastly, we had tangent of an angle is equal to the opposite side divided by the adjacent side. Now, the problem with this is that it only works for right triangles. If you are solving right triangles, this is what you need to use. Today, we're going to look at different types of triangles that are not right triangles. And we're going to start with something that's called the law of sines. So take the time to write this down. You can use the law of sines when you have information of two angles and a side, angle, angle, side, or angle, side, angle. You can also use them for side, side, angle. And you're going to see both of all these cases shortly. So, the law of sine states that the sine of angle A, divided by the opposite side A, is equal to the sine of angle B divided by the opposite side B, which is also equal to sine of angle C divided by the opposite side C. The reciprocal is also true, where you have A divided by sine of A, B divided by sine of B, and C divided by sine of C. So let's see how we can put this into practice. Now if you take a look at this triangle, I cannot use SOHCAHTOA because it is not a right triangle. So I do have our proportions set up for our memory. And now I want you to solve everything about this triangle. So I want you to find the side length AB, angle C, and angle B. So we need to use the law of sine to find angle B, this little guy. And so angle B has to do with side length, the opposite side, 11. What other information do we have? Well, we have angle A and the opposite side, 20. So I'm going to set up my proportion, use the law of sines to find angle, the measure of angle B. So I'm using the first proportion here that you see above. Sine of B over B is equal to sine of A over A. And I'm using this because this is the information that is given to me. Substituting the values, I'm going to solve for angle B because I need to find that angle. So I'm going to multiply 11 on both sides. And I have sine of B is equal to 11 times sine of 115 degrees divided by 20. Now, you can put this all on your calculator and you would get the sine of B is equal to 0.49846, etc. However, if you want to be a little more accurate, you want to leave this little guy the way it is until the very end. Now, before we move further, I want to show you that sine of B is equal to a proportion, or in this case 0.4984. I'm asking for the angle, so hopefully you remember that we have to use the inverse sine because I need to find the angle, the measure of angle B. So sine inverse is equal to what I specified here, Putting this in your calculator will give you more of an accurate answer. You want the calculator to round at the very end. If you round in the beginning, you're going to change your answer, and it's something called the round off error. You don't want that. So by doing this, you'll get a more precise answer. However, if you round that to 0.498, you'll get very, very close. And that will be approximately 29.9 degrees. So that means angle B is 29.9 degrees. Now, to find angle C, I know that the sum of the interior angles of a triangle is equal to 180. So 180 minus 115 minus the newly found angle, 29.9, is equal to 35.1 degrees. Perfect. Now we're going to use this proportion to find the side length C, or side length AB. And I'll explain why there's a difference. It doesn't really matter, it just makes the calculation a little bit easier, and I'll show you why. Here I have C divided by sine of 35.1 degrees is equal to 20 divided by sine of 115 degrees. When I multiply, my variable is in the numerator. When we solve, the variable must be in the numerator. If it's in the denominator, we need to move it to the numerator. And that's why I chose to use this proportion instead of the first one that we did here. However, if you did the one on the left, you would get the same answer. You would just have to do a little more algebra to solve for that C. So C is equal to, by multiplying sine of 35.1 on both sides, 20 times sine of 31.1 divided by sine of 115. Putting this in your calculator, you'll see that C is approximately 12.7. And there. Now we solved my triangle. Let's look at another one. So here we're going to solve the right triangle. I want you to round to the nearest tenth. So I'm going to take a look at to find out what information I'm given. And so I have angle A and its opposite side. And I have a side length here. And I want to find the measure of angle B. So, I'm going to use sine of A divided by A is equal to sine of B divided by B. Now let's substitute some values. I have sine of 40 degrees divided by 16 is equal to sine of B, since I don't know what the measure is, divided by 13. Now notice how the sine of B is in my numerator. This helps me do less algebra. Now let's solve for B. I'm going to multiply by 13 on both sides. And I have 13 sine of 40 degrees is equal to 16, or divided by 16 is equal to sine of B. Now remember, we're looking for the measure of angle B. So I need to use sine inverse. The measure of angle B is equal to sine inverse of this whole guy. So I have 13 sine of 40 degrees divided by 16. You're going to put this in your calculator. If you have a TI 84 or 83, you're going to hit second sine inverse. And exactly what you see is what you're going to put in. 13 sine of 40 divided by 16. And you should get the measure of angle B is approximately 34.5. So here I have 34.5. And I'm going to subtract 180, or I'm going to subtract the other two angles from 180. I have 180 divided by minus 40 minus 34.5. And that leaves me with angle C to be 105.5 degrees. Now, I have all the angles and I have two of the sides. I'm going to do law of sines again to find out C. So I want that C in the numerator. But I'm just going to show you how it can still work even if we used this form. So let's use sine of A again. Sine of A is 40 degrees divided by 16. Let's make that legible. Is equal to sine of C, which is 105.5, divided by little c. So here I have a little bit more work. I need to cross multiply here. And I get C is equal to sine of 40 degrees is equal to 16 sine of 105.5. Now I need to divide sine of 40, divide sine of 40. And now I get C is equal to 16 sine of 105.5 divided by sine of 40. So notice how that's a little more algebra. It's doable, but save yourself the time and use the other, or the reciprocal of law of sines. Again, using your calculator, you will have 16 times sine of 105.5 divided by sine of 40. Make sure you're using enough parentheses so that you get it correct. And we get approximately 23.986. So we're rounding to the nearest tenth, and so C is approximately 24.0. Great. Now you try. Find the value of side B. Hopefully you got it. Let's move on. Using the law of sines, here we have a case where we have two angles and a side. And so I'm going to identify what I have. So I do have angle B and the opposite side of B, little b. And let's take a look at C. So I have sine of B, which is 25 degrees, divided by 15 is equal to, oh actually I have this already. So let's erase this and you will see in a nicer format. So knowing that the sum of the interior angles is equal to 180 degrees, I can find out that the measure of angle A is 48 degrees. And so now I'm going to substitute my values into the law of sines, as you see here. Now I have A divided by sine of 48 is equal to 15 divided by sine of 25. Solving for A, I get A is approximately 26.4. Great. Now let's take a look at C. Here I have C divided by sine of 107 is equal to 15 divided by sine of 25. So solving again for C, multiplying this guy to the numerator, I get C is approximately 33.9 units. And that's it. Let's try another. So here I have B I have angle B, which is 34 degrees, and the opposite side B. However, I don't have anything else. I don't have an angle here, nor do I have an angle here. I can't use the proportion or the law of sines when I have two unknowns or two variables. So this does not work for us. Which brings us to the law of cosines. You can use the law of cosines to solve triangles that give you information for two sides and an angle, side angle side, or when they strictly give you side side side. Now here are three different formulas that you need to remember that solve for the given sides. So looking at the first one, we have a squared is equal to b squared plus c squared minus 2 times bc times cosine A. Take the time to write this down. Let's move on. Okay, here again, we're going to solve the triangle. But this time, we're going to use the law of cosines. So, if you check on the bottom right, I have the three formulas that I've given to you prior. And I'm missing a side B. So, I'm going to use the middle one, b squared. So we're going to use the law of cosines to find the side length B. Here's my formula. I'm going to take all the information that I'm given. Again, 11 corresponds to A, 14 corresponds to C. Angle B is just angle B. Substituting all my values, I have this. And now I'm just going to solve. So 11 squared plus 14 squared is 317 minus 308 from 2 times 11 times 14. And that is approximately 7.9. The way to get there is take the square root of both sides, put that exactly in your calculator, and you will get approximately 7.9. Now we have a little more information left to get. I need angle C and angle A. But to make our lives a little bit easier, let's just use the law of sines, because I do have enough information now to use it. So if you see, I want to find the measure of angle A. Since I already have B and the measure of angle B, I'm going to use that. Substituting the values, I get B is equal to, take a look, it's the exact same equation. And you could put 7.9 since that's B. But remember what I said about rounding. You want to round your answer, not the work in between. So by substituting the square root of 317 minus 308 times cosine of 34 is a lot, it will give you a more accurate answer. So I'm going to multiply by 11 on both sides, as so. And now, hopefully you remember, since we're trying to find the measure of angle A, I need to use sine inverse. Substituting this whole thing into your calculator, the sine inverse of everything you see there is approximately 51.6, which means that this angle A 51.6. Now, since we have two angles, I can subtract 34 and 51.6 from 108 to get the measure of angle C, which is approximately 97.4. Great, let's keep going. So now I want you to try. Find the measure of angle B. What did you get? Great. Hopefully you got that right. Let's take a look at another. Here we have the information given for all the sides, hence your side case. Now it's a little more involved because if you notice, every time we have an angle, it's all the way multiplying to the back of the equation. It's just a little more algebra, but again, doable. So I'm going to take a look at my second one again. But in this case, you can use any, substituting the values. Again, this is my A, this is my little b, and my C. And I'm trying to find the measure of angle B. So here, I need to solve for cosine of B. So I'm going to subtract 12 squared on both sides, subtract 20 squared on both sides to get 27 squared minus 12 squared minus 20 squared is equal to, is equal to negative 2 times 12 times 20 cosine B. Now I must divide negative 2 times 12 times 20 to isolate cosine of B. And that looks like this. Again, I'm trying to find the measure, so I need to use inverse cosine. Using inverse cosine, I get approximately 112.7. If you'd like to see how that looks in a calculator, you want to type in cosine inverse of 27 squared minus 12 squared minus 20 squared divided by negative 2 times 12 times 20. That will get you your answer for the measure of angle B. And now I need to find some other things. I'm going to use the law of sine to find angle A. That is less work to do than law of cosines. So let's take a look. Sine of A divided by 12 is equal to sine of 112.7 degrees divided by 27, which is equal to sine of A is equal to what you see there. Using sine inverse again, I get the measure of angle A is approximately 24.2 degrees. And now 180 minus 24.2 minus 112.7 is equal to 43.1 degrees. And there you have it. I solved a triangle. And that's it. Hopefully this was informative and intuitive. If you have any questions, feel free to let me know. I'll be happy to answer them. Have a great day.